So when you click on confidence intervals for proportions, we see a screen like this. And this right here is on that page in your packet, this little piece over here. Printed right here. All right. So if it's not already set like this, looking at number 1 here, we're going to set the population proportion to 0.5. We're going to set the confidence level to 95% and the sample size to 75. So I want the population proportion at 0.5. There's a little slider here for your population proportion. You want this to be right at 0.5. Confidence level, we've got a slider for this one as well. We're going to set our confidence level at 95%. And what was the sample size that we wanted? 75. Sample size N. Right now I've got mine is set at 20. I need to drag this over until I see 75. So I'm going to set it at 75. Once you have the population proportion, the confidence level, and the sample size set, let's go down and read number 2 in your packet. We're going to click sample, not sample 25. We're just clicking that top button that says sample to choose a simple random sample. And we are going to display the confidence interval, which is what we learned how to calculate yesterday. So when I click sample, there's my confidence interval. And I want you guys to sketch that. Whatever yours is, I want you to sketch it onto that graph that you have there. So you kind of have a record of this. What was the true population proportion? 0.5. Did my confidence interval capture that? I want you to answer on your page whether or not your confidence interval captured it. I'm guessing most people in the room, the confidence interval captured 0.5, but not all of them will. Back one page. Right there. There you go. So after you have done this once, I want you to do it 9 more times so that you have 10 confidence intervals on there. You're just going to hit sample again, and it'll show you your next confidence interval. Sample again, and it'll show you your next confidence interval. I want you to do this 10 times and to sketch all 10 of them on there. Then I want you to determine, after you've done that, how many of those 10 confidence intervals captured the true population proportion of 0.5. You want all 10 confidence intervals sketched on your page, and determine how many of those 10 captured the true population proportion. Yes, sir. of 10. You just had that one at the end that didn't, right?
Last one.
Yep. That's exactly what I want to see. So when I did the exact same thing up here, the only one on mine that missed that true proportion was the very first one. Did anybody get all 10 confidence intervals that captured the true proportion? Did anybody have less than 9? Less than 9 that captured the true population proportion. All right. I want you to hit reset. We're going to take a total of 100 confidence intervals. So we're going to do this sample 25. We're going to do it 4 times. So click sample 25. If you look down here, it tells me 23 of them captured the true population proportion out of a total of 25. I want that total to go up to 100, so I'm going to sample 25 again. Now it's gone up to 50. I'm going to sample 25 again. Now I'm at a total of 75, and I'm going to sample 25 one more time. Let's see. On mine, I had 90 out of 100 that captured the true population proportion. Aiden, what did you get? 96 out of 100. Joan, what did you get? 97 out of 100. Cassandra, what did you have? 97 out of 100. Xavier, what did you get? 94 out of 100. Are these results surprising anybody? Not necessarily. What did we set our confidence level at? 95%. All of these numbers are hovering right around what? When we repeat these trials over and over and over and we calculate a confidence interval for each one of these samples, about 95% of the time, we are capturing the true population proportion, or about 95 out of every 100. Some people a little higher, mine was a little bit lower, but it's hovering right around what we set our confidence level at. I want you to see what happens to your confidence intervals if you drag this little slider for the confidence level over to 99%. What happened to those confidence intervals? What happened to each and every one of them? They got wider. When they get wider, do more of them or less of them capture the true population proportion? More of them. On mine, it went up to 95 out of 100, so almost all of them. What happens if I slide it back the other way? If I take it to a confidence level of 90 or a confidence level of 80, what happens to them? We started at 95. If I drag it the opposite direction, what happens to all of my confidence intervals? The amount of hits gets smaller and my interval gets narrower, it gets tighter. I want you guys to jot some notes down on your page. Watch your confidence intervals as you drag the confidence level from 95 to 99%. We're not hitting reset. What did we say happened to the confidence interval when we went from 95 to 99? Yes, my confidence intervals got wider. More of them are capturing the true proportion. If I want to be more confident, I need a wider confidence interval. Once you get that written down, I want you to look at number 5. I want you to hit reset, take your confidence level down to 80%, and I want you to do 100 samples, so sample 25 4 times, and write down what percent of the intervals are capturing the true proportion. At the 80% confidence level, change that. No, I wanted it at 80%. I don't know why mine is not letting me stay at 80%. See, Justin, how many of yours captured the true population proportion when you had an 80% confidence interval? 71%. Grayson, what about you? 78. Emma, what about you? 83%. 83 out of 100. I want to interpret that confidence level. So let me pull my screen up so you guys can kind of get this copied down into your notes as well. So we're going to interpret this confidence level. Somebody said, sorry, Emma, what did you say yours was? 83%. 83% of the intervals captured the true proportion. Our formal way to interpret a confidence level is that if we take many, many, many samples and we calculate a confidence interval for each, we expect about 80% of them to capture the true population proportion. So an 80% confidence interval. I want to make sure you guys get this language down. If we take many, many, many samples, and calculate a confidence interval for each, we expect about 80% of them to capture the true population proportion. When we set our confidence level at 80%, was it exactly 80% of them? No, but it was ballparking around there. And if we do this many more times, we're going to get closer and closer and closer to 80% of them capturing the true population proportion. When my confidence level goes up, this I want you to put alongside whatever you wrote down on number 4. When our confidence level increases, when we took it from 95 to 99%, what did you tell me happened to the intervals? It got wider. What were we doing yesterday to construct those intervals? We found our point estimate, that was our p-hat. How are we constructing these intervals? What did we do to go from just a point to an interval? We added and subtracted. Does anybody remember what we called the thing that we were adding and subtracting to that point estimate? Starts with an M. What'd you say? Margin of error, yes. When my confidence level goes up, my margin of error goes up. Because that's what gives me a wider confidence interval. I want to see what happens when we adjust our sample size. So I'm going to go back and look at this. We're going to do one sample that has a sample size of 20. And then we're going to do it again with a sample size of 250. So I want you guys to look at this. I'm going to go ahead and hit reset. I'm going to leave it at a 95% confidence interval. I'm going to take my sample size down to 20. And I'm going to hit sample. Look at that confidence interval on yours. And now I want you to set the sample size to 250 and hit sample again. What happens when you have a larger sample size? Margin of error got smaller. As my sample size goes up, my margin of error gets smaller. The interval became much narrower. As the sample size goes up, the variability of the sampling distribution goes down. Or same idea off to the side. As n goes up, my margin of error goes down. If I want my confidence level to go up, my margin of error is going to go up. If I increase my sample size, my margin of error will go down because I'm tightening up, I'm reducing variability. Think about it in terms of standard deviation. As my sample size gets bigger and bigger and bigger, my standard deviation gets smaller and smaller and smaller. So it's going to get tighter and tighter and tighter. Sample size goes up, margin of error gets tighter. Does that make sense so far? Right. That's our big ideas for today. I want to interpret a confidence level. So again, interpreting a confidence level, we would say if we take many, many, many samples and we calculate a confidence interval for each about blank percent, whatever our confidence level is at, about that percent of them will capture the true, whatever my parameter is, in context. When I want to be more confident, I have to increase my interval, so my margin of error is going to increase in order for me to be more confident. I can decrease my margin of error by increasing my sample size. The margin of error accounts for sampling variability. That's why we calculate this interval, because we know there's variability in sampling data. Margin of error does not account for different types of bias. It does not account for non-response bias or undercoverage bias or response bias. Does anybody remember what those different types of bias mean? What is a non-response bias?
People who didn't respond.
People who didn't respond. They were asked, but they chose not to respond. Non-response. What is undercoverage bias? Yes. What'd you say? Yes, Joan, what did you say?
Who's missing not covering the true population?
Not covering the whole true population, yes. Like you're, whether it's intentional or not, you're kind of systematically leaving out a group or groups of people that you consider to be part of your population. What is response bias? We had non-response bias, that's just not choosing to respond. Like you get an email and you're like, I'm not answering that. What about response bias?
The question is worded in a tricky or confusing way that's going to push people towards one answer.
Absolutely, absolutely. So if I started a question like, since we know that Mrs. Bellington is an amazing teacher and everybody would be so lucky to have her for AP statistics, on a scale of 1 to 10, how would you rate her? It's a very leading question. If you lead with a lot of positives or you lead with a lot of negatives, you're kind of guiding the responses you're getting back, and you might not get people's true feelings or their true thoughts. Non-response bias, I tend to think of like Yelp reviews. People that are going to choose to respond are either very, very happy or very, very unhappy. People that feel somewhere in the middle usually don't write Yelp reviews. When you guys are finished capturing all of this onto your page, I want you guys to try to check your understanding down below. I want you to answer those 4 questions there. Interpreting the confidence level that was given. Explaining what would happen to our confidence interval. And describing a possible source of bias. What in the world? Okay, sorry. I don't know why it did that. There we go. Sorry about that. About 5 minutes or so, and we're going to go over the check your understanding. how would we interpret the confidence level here? It says the gym teacher determines he is 90% confident that the interval from 24.1 to 28.5 captures the mean number of push-ups that students at this school can do in 1 minute. So how would you interpret the confidence level, Aiden?
If we take any minute samples and calculate the confidence interval for each, about 90% of the calculation factor of the number, or the mean number of push-ups students can do.
Yes, so the only thing I would change about that is our parameter here is the mean. So it would capture the true mean. Yes, that's the only thing that I would change about what you said. If the gym teacher takes many, many samples and calculates a confidence interval for each, about 90% of them would capture the true mean number of push-ups for students at this school. What would happen to the length of the confidence interval if the confidence level were increased to 99%? What would we see happen? Margin of error would increase. So my intervals are going to get wider. My margin of error increases. Yes. How would a 90% confidence interval based on a sample size of 200 compare to the original confidence interval? Or the 90% interval?
Would you less than the original?
Yes. Margin of error is going to decrease. It's going to get narrower. Absolutely. What is one potential source of bias in this study that was not accounted for by the margin of error? We listed 3 possibilities. What do you think one would be here? Yes, Justin. Under coverage. Why? I agree.
The PE teacher only picks students who stay after school for sports practice, but he says he wants to estimate the mean number of push-up students can do at the school.
Yes. He's saying his population is the whole school, but he's only pulling his sample from student athletes who stay after school for practice. So he is not sampling from his whole population. So under coverage bias, absolutely, is what I would have for this one. And the margin of error is not going to account for that at all. Awesome. With our last couple minutes, I'm going to go ahead and pass back the test that you guys took on Friday so you have the opportunity to see that and see your grade. Ask me any questions you might have about that. I do need these back from you, so before you leave the room, either hand it to me directly or put it in the test basket.